Welcome to the Blazor ComboBox component tutorial. In this video, I'll show you how to perform semantic filtering in the Syncfusion Blazor ComboBox component. This makes it easier to find relevant data without needing perfect matches. For example, searching for school, it returns results like education or study materials, enhancing the experience by showing related options through local embeddings. Now I'll open an existing Blazor web app where I've already added the Syncfusion Blazor ComboBox component, with data source property is bound to the filtered categories for selection. If you want to learn how to add the Syncfusion Blazor ComboBox component to a Blazor app, check the video linked in the YouTube card above or in the description below. Let's run the example application. As you can see, the ComboBox component is rendered with the given placeholder. Clicking the drop-down displays the list of categories. When I type a specific item, notice that the matching item is selected. Next, let's implement semantic filtering. To do that, I installed this Smart Components Local Embeddings NuGet package. Next, I'll open the client-side program CS file, added the required namespace, and registered the local embedder class as a singleton service within the app's dependency injection system. Ensure that you also need to register the local embedder on the server-side program CS file. To begin, inside the home Blazor component, I create the onInitialized async method. This life cycle method runs automatically when the component is first initialized. Before proceeding into the filtering logic, I'll make some updates to the existing code for better structure and reusability. Instead of initializing the expense categories inline, I update the initialization to a separate method called loadExpenseCategories. This improves readability by separating data setup from the component logic and ensures reusability across the application. Next, I declare a list named AllCategories to hold all available categories. Additionally, I create another list called Filtered Categories to store the filtered set of categories dynamically based on the input. Inside the onInitialized async method, I assign the expense categories to the AllCategories list using the loadExpenseCategories method. I then initialize filtered categories with the same data. This ensures that the ComboBox displays all categories when it first loads. Next, I'm going to implement semantic filtering for the expense categories using embeddings. To access the embedding service, I include the Smart Components Local Embeddings namespace in the component's code, and also inject the local embedder service. First, I declare a dictionary named Category Embeddings, which maps each category ID to its corresponding embedding vector. To generate embeddings, I use a for each loop to iterate through all categories. Inside this loop, I create a numerical vector for each category name using the embed method. These embeddings are then stored in the Category Embeddings dictionary, using the category's ID as the key and the embedding as the value. To enable filtering in the ComboBox, set the Allow Filtering property to True, allowing you to type and dynamically filter the list, improving usability for large datasets. Next, I define the ComboBox event stack and set the data types for the ComboBox value and list items. I also add the filtering event, which triggers whenever the user types or modifies text in the ComboBox, updating the list dynamically. To filter the ComboBox based on semantic similarity, I create a private asynchronous method named handleFilteringAsync. Inside the method, I get the text that typed into the ComboBox. If nothing is entered, I assign it an empty string to make sure the code works without errors. If the search box is empty, I reset the filtered list to display all categories, ensuring all options are visible. But when there is a search term, I use the embed method to create a special embedding for the input and compare it with pre-computed embeddings for the categories to find matches. To decide which matches to include, I declare a private double variable called similarity threshold and set a value of 0.65. This means only categories with a similarity score higher than 0.65 will appear in the results. I also create a reference for the combo box called expense category combo box and bind it to the ref attribute. This allows me to directly access the combo box when needed. Next, in this method, I compare the embedding of each category to the input and filter out any categories that don't meet the threshold. Then I call the combo box filter async method with the filtered list to update the displayed options. Finally, I bind this method to the combo box filtering event. I also update the placeholder text in the combo box to let you know the semantic filtering is being used. Let's run the example. When I type transport, you will see the relevant data filtered. Similarly, typing dress will filter and show the relevant categories. Now let me summarize. I've shown you how to use the semantic filter in the Syncfusion Blazor ComboBox component. If you want to see the working code for this example, you can download it from the GitHub link in the description below. I've also provided a link to check if you qualify for a free community license to access all our Blazor components. If you found this video useful, don't forget to click the like button and subscribe to our channel for more videos like this. Thanks for watching.